Hi guys, hope you're all doing well. So today we're going to take a look at inequalities and how to solve official questions of that. This is one of the most requested topics for a webinar. So I decided that let's put all inequalities questions together. Essentially, I took all the inequalities questions, the official questions, which were 655 plus. I started out with 705 plus, but then there weren't enough questions. So then I picked up all the 655 plus questions of inequalities and I have split them into 3 groups. So today we're going to take a look at group 1, where we're going to discuss how to solve pure inequalities questions. Maybe, a slight introduction to absolute values perhaps, and a slight introduction to must be true concept as well. Then next week, we are going to take a look at inequalities in the must be true format, which adds that additional bit of complexity, and it becomes extremely hard to make the learners understand that. So we are going to tackle a lot of must be true questions so that it just becomes intuitive to you. Yeah. And then the week after that, we are going to again look at inequalities must be true questions, but the ones that we would preferably solve using number properties that we discussed. If you remember, we discussed what are the various properties of the exponents on the number line, right? A lot of the the inequalities questions I've found, can be much better, much more efficiently done using those properties. So that is what we're going to take a look in webinar number 73. So today 71 inequalities today, with slight bit of introductions to other topics. Inequalities and a little more of absolute values in 72. In the must be true format, and inequalities and must be true using the number properties in 73. Yeah. So, in these 3 webinars, then we'll ensure that we have covered all types of inequalities questions. Now, the questions I'm going to take today, they are not official questions. Let's call them, official lookalikes with a little extra complexity. So you still have those official questions for your own practice. I'm sure, I'm not going to take those away from you. I'm sure there's a lot of relief and comfort when you're able to solve official questions, right? So we'll leave those, but these are based on exactly the same concepts, exactly the same framing, exactly the same wording, everything, just that the numbers are different and there is a slight bit of extra complexity over here. Yeah. All right. So let's start with today's webinar. I'll share my screen. Give me a moment. All right, how many of the integers that satisfy the inequality? So what do I have? I have this particular inequality. This reminds me of what? Inequality is where there are factors given to me, right? And I know how to solve that. We use the wavy line method. Now, that is the one which is most often used for your inequalities questions in your official questions. Yeah. So think about it. When you see an inequalities question, ask yourself, is it using the wavy line method? This one is, factors are already there in front of us. All right. So I have an x plus 1. I hope you guys are comfortable with the wavy line method, right? We've discussed it in detail in the content, right? All right. So this is the inequality that we have. All right. So I have, remember, what do I need for the wavy line? I need the factors to be of the form x plus or minus a, right? So essentially x minus a. So x minus of minus a or whatever. So here, these factors are all right. This is fine. This is x squared. We'll talk about it in a moment. This is not in that format. So what do we do? Because, this is in the form of ax plus b, right? So what do I have to do? I take out the 2 and I write 2 outside, and this becomes x plus 2, right? No worries over here, no issues. Yeah, we just took 2 out of this particular bracket. All right, now I have factors of the form x plus or minus a. Yeah, I'll make my line, my number line. Yeah, and I will plot these points on the number line. These are the transition points. Guys, I hope you remember the wavy line method. We'll not go into the details of that. We have discussed it in detail, right? So I hope you remember how to solve these questions, right? So x minus 1, this is the point. This is, I'll plot 8 over here. This is x squared, right, into 2. So x squared, that means that the transition point is 0. Now, am I going to plot 0 over here? I'm not going to. Why? Because it has an even power. So when I have x square, for example, my sign does not change at x square, because whatever x is, positive or negative, it just becomes positive or 0. Of course, in this case, it cannot be 0 because it's in the denominator, right? I am not going to plot 0 over here because the sign will not change at x is equal to 0. Fine. Now this I'm going to plot as -2, right? Because this is x plus a, x minus of minus a. So I'm going to plot a -2 over here. All right, what do I need? I need this entire thing to be less than or equal to 0. Less means that it'll look like this, my wavy line curve, whatever, right? This is what it is going to look like. So I know my rightmost side is always positive. Here it is going to be negative. Here it is going to be positive, and here it's going to be negative. All right, equal to is also possible. So then I know my x can be 8. So great, I have this point. I know my x can be -1, equal to is possible. All right, then I have this point. Can my x be equal to -2? Is that possible? What about this 2? Are you worrying about why didn't we do anything with this 2? This 2 doesn't change the sign of the expression, right? We are concerned about the sign of this particular expression. This 2 doesn't change it. So my constants are totally to be ignored. I don't have to worry about my constants at all. Now I have my -2. Can x be equal to -2? Is this possible? No, it is not possible, right? This thing is not possible. Why? Because it's in the denominator. My x cannot be equal to -2. If x is equal to -2, my denominator will become 0, which is not allowed. GMAT only deals with real numbers, which means that x cannot be -2 even though I have less than equal to sign over here. It just means that -1 and 8 are possible. Yeah, cool. Okay, so then integers, I need integers. This is not there. I know that my -1 is absolutely fine. Sorry, these are positive numbers, right? So I'm talking about the numbers over here. I need less than 0. So I'm talking about the negative numbers, of course. Yeah. All right. Now, x has to be greater than -4 as well. So my -4 is over here. Yeah. I want the values of this particular expression, the negative values, because I'm looking for less than 0. This entire expression should be negative. And I know it is negative in this particular range from -1 to 8. And I know it is negative in -4 to 2 range. Remember, start with positive and then positive, then alternate positive, negative, whatever, as many sections that you have of the number line, right? Okay, so now from -4 to -2, -2 is not included, -4 is not included because I need greater than -4. How many numbers do I have in this section? Integers. I only have one integer, which is -3. So I say, okay, I'm going to count this one. All right. Now from my -1 to 8, all these numbers are inclusive, right? My x can be -1 because it's in the numerator. So this is allowed, and all the integers in between -1 and 8 are allowed. Now, how do I get my integers from A to B? Let's say if I say how many integers there from 25 to 36. Yeah, sometimes you can get a little confusing and I want to include both of them. What do? I say this is 36 minus 25 plus 1. And this is something we have discussed also. We have talked about it. Why is it plus 1? Because when I subtract, I'm subtracting the first 25, but I don't have to subtract all of them. I want to include my 25 as well. And that is why I add a plus 1 over here, right? So this is how I count my number of integers from A to B. So now I want my number of integers. Look, I'm not going to do counting on my hands, or, I mean, I shouldn't make an error. Let's say I'll not. One way is to say, okay, this is 0. And so from 1 to 8, I have 8 numbers, and then I have a 0, and then I have a -1. Or another way is simply to say 8 minus of -1 plus 1, which is equal to 10. Yeah. All right, so I have 1 point over here and I have 10 points from -1 to 8. All of them are there. Now, please keep in mind, what is the role of this x square? Here, I do not plot the x square because it is not going to be negative. It's not going to change the sign of the expression, but I do get something. When I see x in the denominator, Whenever I see something in the denominator with an x, I write over here. The moment I see it, I'll say x not equal to 0. If I do not write this, I'm going to make a mistake in this particular question. Why? Because I'm going to see from -1 to 8, all points are inclusive. I'm not thinking about that 0 at all, right? And that is why I am going to end up getting 11 points. But there are not 11 points, there are only 10 points. Why? Because this -3 is 1 point, and then from -1 to 8, the 10 points are there, but 0 is not included because we cannot let x be equal to 0. And that is the reason why answer is A over here, and we have 10 points. And all of you who've made a mistake on the question had given me the answer as 11. Why? Only because you included the 0 as well. Yeah. So the moment I see a variable in the denominator, something, I should write down, even though, we don't like to write stuff and we like to just do everything orally and everything. But please remember, there are some things which we tend to, where we'll make careless mistakes. Yeah, it is possible that it's maybe a simpler question. We'll end up losing marks. There are these things, these hygiene factors that we call them, right? We have to ensure that we don't make a mistake there. So I will write x is not equal to 0 on my scratch pad the moment I see that there is a variable in the denominator. Is that okay? So here our answer is going to be 10.